Hello guys, welcome to the channel. I hope you all are fine and doing great. Today we are going to discuss this single valued subtree problem of GFG. So let's move on to the problem guys. Here we are given a binary tree and we have to count the number of single valued tree. What is single valued tree? Suppose this is a tree like this is any tree. Don't go on the drawing but just look at the structure. This is a tree. So we have to find out the single value tree, and single value tree is a tree. Suppose if value of all nodes is 1 or 1 rather should be x, any value x, common value, all the nodes have value x, then we can say this is a single value tree, means all node have single value, so it is single value tree. So we have to so guys, we have to count the number of these single value tree. Suppose we are given this. Okay guys, so we are given this structure, suppose for a minute. So how many single value tree we have? Just mark them. Okay, take some bold marker with this color. Okay, so here we can see, is one a single value tree? Is one a single value tree? Yes, it is. Why? Because all the nodes in my one tree are contain single value. How many nodes? Single node. It is null. It is null. Single node is always a subtree. Okay, subtree means all the, like this is the root node. Subtree means this is a root node and all the children of it will contain in this subtree. Like for this one I can say this is my subtree. For this two I can say this is my subtree. For this one I can say this is my subtree. Okay, so from a current node, a subtree is a tree that will contain all its children nodes, all everything about its children node. Okay guys, so here one is a like single value node. Two is, now this one is no, its value is equal to its value, its value is equal to its value, its value is not is equal to, so these are not equal, so it cannot be a, or we don't mark it. So here one is okay, so before one we have to check for right as well. Like suppose here it is 1 but it is 2, so it cannot be a single value tree. So when it is not a single value tree, how can this complete be a, okay, so we have to check all branches. Like for a particular node to be a single value tree, its left node subtree should be single value, its right node should be single value. Why? Because if once I check its right and left subtree, then we can easily check this. How? This is 1, this is some x, this is single value tree, all the all its children contain x, this is something y, and all this is some node y, and all of its subtree contain y value, y, all the nodes contain value y. Now this is a single value tree, this is a single value tree. For one to be a single value subtree, what should be the condition? X should be a single value tree, y should be a single value tree, and means they both are same value. Like suppose here if one is not is equal to 2, it is not a single value tree, so this cannot be a single value tree, because all the subtree of a particular node also should be a single value tree. Only then a complete tree can be a single value tree. Okay guys, so here, and this condition should be satisfied, means one is single value, y is single value. Now the second condition is x value of x should be is equal to 1, or take it current, this is my current node, c node should be equal to current value, means this is a single value tree and the value of this particular tree is equal to this node, then we can say this is a single value tree. But now because this is also part, so we also compare this tree. If this complete are equal, then we can say 1 c x y is a complete single value tree. So and y value means the value of y node, because it is a single value tree, so every will contain same, so only we can see check only for right node. So y value should be equal to c value, or we can see it left and right. Left node value should be current node value, right node value should be current node value. If these three conditions satisfy, I can say this is single value tree and every node contain value equal to cv, because why rv, this is rv is equal to cv. We can say x or l is a single value tree and a value of these two are equal, so we can say all the nodes contain value cv, this contain value cv, this contain value cv, this also value cv, current value node, so this all will be a single value tree. Okay guys, this is what I want to say. we check left, we check right, then we will check this condition. These both children subtree should be single value. Value of left and current node should be equal. Value of right and current node should be equal. So very easy. Go back to the example. This is true. We all know. We all know. So now this 2 is a single value tree. This 2 is a single value tree. Complete node. Here it is equal to null. We does not care about it. This is the this is a node that are exist in my subtree. So this 2 is a single value tree. Now this 1 is a single value tree. This is a single value tree. This is not a single value tree. So this cannot be a single value tree. Okay guys. And suppose one more condition. One more condition. If this is equal to 1, this is equal to 1. Now suppose for this example, this one is a single value tree, this 1 1 1, this single value tree, this is single value tree, and value of 1 1 is equal to, so this is now left is single value tree, right is single value tree, but can this be a single value tree? Here we can see for this particular tree my xy single value tree condition satisfy. L value of left is equal to value of curve satisfy, but either this condition satisfy, value of right is not is equal to value of right node should be equal to current node value. This condition false. So these three condition are not satisfied. So we can say this cannot be a single value tree. So we will return false from here. Means all the above part it cannot be a single value tree because one of its children is not a single value tree. Because suppose if here is one, here is some part, this is a children of one, this node is a children of this one, can this one be a single value tree? No, never. Why? Because its subtree is not a single value tree, means one contains some portion that will not contain value is equal to 1. Okay, this, so we cannot we can say this is not a single value tree. So how we will do it? We'll take a variable answer that will store our count, we will call a function solve, then we will just return answer. Now if my r is equal to null, we can simply return 1 because here we can see to this part is null, but it will never create a mess for us. This will not be important. Now we take three values. Current is equal to r data, means current node value. L value will store the okay, so instead of r value you can say it is either 0 or 1. 0 or 1. 0 means it is not a single value tree, 1 means it is a single value tree. Okay, same for r as well. Now if my r value is equal to 0 means r is not a single value tree, or my sorry, L is not a single value tree, or my r is not a single value tree. Means either left or right children is not a single value subtree. So we need to return 0 because if children is not a single value tree, it cannot be a single value tree. We just need to return 0. First condition. Second condition, what is? The left node should be exist and the value should be equal. R dot left data means the value should be is equal to current. If value is not is equal to, means its left node exist and its value is not is equal to my current value, means it cannot be a single value tree. We will just return 0. Similarly for right, if my right exists but the value of right node is not is equal to current value, just need to return 0. Else why my all three conditions satisfy, we will increment the count and return 1, means it is a single value tree. Not so hard to understand, but just like constructive type algorithm. So guys, you can see all the 131 test cases pass out. I hope you will understand the problem. If you have any doubt, then just comment out. I will try my best to explain you. Please subscribe the channel, like the video, and check out my channel for more these type of videos. Thank you for watching this, guys. Stay tuned.